In this problem, I would like to discuss the area under the curve, but if you take a look at the problem carefully, I didn't tell you what the function is. So f of x, what is that equal to? We don't know, but you have a picture. So you have to do some work on this picture in order to figure out the area under the curve. So I want you to use 6 subinterval and then find left sum using 6 subinterval. So based on what I wrote right here, the domain of the function is from 0 to 12, and I want to divide this into 6 subinterval. Before we do some work on this picture, I would like to give the picture credits to the Calculus Early Transcendental 8th edition by Professor James Stewart. It's a fantastic book. A lot of colleges and universities use this book. I use this book to finish my calculus class. Okay, so back to the problem. So first you need to do 6 subintervals, right? So here is how I do it. So before we do any works on picture, I draw a point. This is the starting point 0. And then the end point is 12. So this one is 12. You need to divide this into 6 subinterval. That means you have to make 5 cuts. So first I make a cut right here. So that is 1, 2, 3, 4, 5. But how long is each cut? You cut that into 6 pieces, right? 1, 2, 3, 4, 5, 6, 6 pieces. How long is each piece? So when you look at a textbook, they call the width to be the delta x. The triangle is called delta x. Delta x means the width of an interval. So they take the maximum minus minimum and then divided by 6 subintervals. So 12 divided by 6 is equals to 2. That is called delta x. It's called the width. So this is called the width of a subinterval. So each subinterval is length 2. So from 0 to 2, 4, 6, 8, 10, 12. All right, so let's move on to the picture. So let me use a different color to do the works on picture. So from 0 to 2, 4, 6, 8, 10, 12. All right, so since this is the left 6, so that means we go from left to right. So left to right. Okay, starting on the left, all the way to the left. Where is the first point? The first point where? The first point on the curve. Again, a point on the curve. That point must be on the left. Okay, left. So all the way to the left, we have a point right here, right? So we have a point right here, and then we shoot a line from left to right. The line is 2 units long. So that is 2 units long, and then we go all the way down to the mark. So that is my first interval. And then at x is equals to 4, we have a point on the curve. Again, a point on the curve, not on a random position, a point on the curve. When x is equals to 4, this is a point on the curve. Oh, sorry. When x is equals to 2, not 4, not yet. When x is equals to 2, this is a point on the curve. Then we should align from left to right, and then we line up the 4. So that is my second rectangle. And then the next one, when x is equals to 4, we have a point on the curve right here and then right here. So let's highlight the rectangle. So this is the first one, and then this is the second one, and then this is the third one. And then the next one, when x is equals to 6, we have a point on the curve. So that's the next rectangle. When x is equals to 8, a point on the curve. And then when x is equals to 10, a point on the curve. We have that. Now, and answer a question for me. Do we need to consider x equals to 12? Do we need this point? Do we need it? The answer is no. We do not need a point at x equals to 12, because if you take this point, you should align to the right. There is nothing. That is already out of the domain. So therefore, we do not need a point at x equals to 12. So get rid of that, and then get rid of that. We are all done. So we have 3 rectangle, right? So this is the fourth one. The fourth one, 6. 1, 2, 3, 4, 5, and then 6. Right. 6 rectangles. Okay, now the next step is I want you to find the area of this rectangle. What is the area of a rectangle? The area of a rectangle is base times height, right? So the first one right here, let's switch to another color. So this one, the first one right here, what is the base? How long is the base? The base is 2 units long, and then how tall is the rectangle? This determines the height, right? Okay, here. This determines the height, right? This point, this red point determines the height. In order to find the point, you have to plug in a point to the function. This function is called f of x, and then this point is at x equals to 0, so you have to plug it in when x is equals to 0. What is the function equal to? So when x is equals to 0, the function, the height is at 9, so that means 2 times 9, that is equals to 18. So 2 times 9, the first rectangle, the red rectangle you see on the picture, is 18. If you count the boxes, that is 18 boxes, right? So you have 9, right? 9 by 2, 18 boxes. Okay, let's do the entire line. All right, so the entire line, so we have a left sum. I divided into 6 intervals. So from left to right, the first one, the base is 2 units long, and then we have f times 0, right? And then the next one is the base is 2 units long, and then we are at f of 2, and then plus 2, f of 4. If you take a look at the orange segment, so 0, 2, the next one is 4, and then we use 6, we use 8, we use 10, but we don't use 12. And then 2 times f of 6, so that is right here, and then plus 2 f of 8, and then plus 2 f of 10. F of 10 right here. Now, answer a question for me. Do we need this? Do we need this? The answer is no, we do not need it. Why? Because if you are at x equals to 12, right here, right? X is equals to 12, you should align. There is no rectangle because that is already out of the domain. So therefore, we do not need F12, okay? So get rid of that. We do not need this. Get rid of it. We don't need it. Okay, so there is another way to write it. Depends on which textbook you use. Some textbook, they factor out the 2, and then they put the f of 0, the f of 2, and then the f of 4, 6, 8 inside a square bracket. And then don't forget f10. And then this one, how do I know I use 6 intervals? So here is how you do the count. 1, 2, 3, 4, 5, 6. 6 intervals. Okay. Now, the next thing is 2. F of 0, so when x is 0, the function is equals to 9. You can check out the picture. The function is equals to, the y value is equals to 9. And then when x is equals to 2, this can be a problem. When x is equals to 2, this is one thing that I don't like, this type of problem. When x is equals to 2, let me change to another color. Let me change to blue. When x is equals to 2, we have a point right here. So if you line them up to the y-axis, it is a number that is so close to 9, right? So this one you really have to guess. When x is equals to 2, this one is 8.8. It's close to 9, not 9. I will call this 8.8. Then you might argue with me, hey, can I let the y value be 8.7 or 8.6? The answer is yes. If you let that be 8.7, I cannot argue with you because you are trying to eyeball the picture. But what if that is an exam problem? In my class, if I do an in-class handwritten exam, I will just give you a table value. Okay, so I will give you a picture, and then on the right hand side, I will give you a table value. I will give you the numbers that you need. So you don't need to guess. That's how I do my exam. I will provide a table. So there is no need to guess on the exam. But since this is a in-class discussion, I can just say that we guess. All right. Okay, back to the problem. And then f of 4. So when x is equals to 4, we have a point right there. We have a point right there, the red. So when x is equals to 4, we have a point right there. I will just call this 8.2. So this one is 8.2. When x is equals to 0, so x is equals to, why do I put a 0? 6. when x is equals to 6, we have a point right here. So that is around 7.3. 7.3. And then when x is equals to 8, x is equals to 8 right here. Y is around 5.9. So 5.9. And then finally, when x is equals to 10, we have a 4.1. So when x is equals to 10, that is a little bit higher than 4. So I call this 4.1. Again, if I put this exact same problem on the test, I will give you a table value. You don't need to guess. Okay, so this one, add and then multiply. I am sure everybody can do the job right. That is equals to 86.6. So do you see that f is a decreasing function? Right, it's a decreasing function. The question didn't ask for that. Is this an overestimate or underestimate? The answer is this is an overestimate. The reason is every time you have a rectangle, so let's do this in red. Every time you have a rectangle, you have a piece that sticks out of the function. So every time you calculate the area of one rectangle, you have an overestimation. The overestimation is the yellow region right there. So if you accumulate this kind of overestimation, at the end of the day, you have a big overestimate. So overestimate. So regarding the matter of overestimate and underestimate, you have to use your eyes to look at the picture and then make a decision. So that will be the end of this video. In the next video, I will do a right sum. I will see you all in the next one. Before I close the video, if you think my instruction is helpful, like the video, subscribe to my channel for me, share the video out if you want to. Thank you for your help and support. I see you all in the next lesson. Signing out for now.